Well, hello friends. Today we are going to implement popen or popen for the C library because I had a friend who always used to use popen for everything, and I remember thinking he was crazy, but he somehow managed to solve all kinds of problems using popen and then just doing shell commands in his C code. God bless him. But yeah, so I just I just thought of that guy today and figured I would make popen in case he ever comes to Serenity, and he'll have it there. Okay, so this, I guess I'm just looking for the new version of the POSIX docs here. So I never really used this myself, so I have to look it up. So popen is basically you tell it, hey, run this command as if you're doing it with like a system libc call, but instead of just letting the command spew its output to standard out, you instead send it to a file, like a file star, or an stdio file stream, basically. And let's see. And I guess maybe you can also use it, yeah, so you can use it to provide input to the child process as well. Okay, so I've only ever seen it being used to send the output somewhere so that I can read it, you know, like I call popen and I read it, but I guess we should do both. So let's just get started. So let's go in stdio, and it looks like I have these function declarations here from before, but they're not implemented, so I bet that I just added those when I was trying to port something, and then it turned out that they were never actually called. We just needed definitions so that we could link. Anyways, now we are going to need to implement both popen and pclose. I guess we can just start right away. So what's it gonna have to do? I guess it's gonna have to create a pipe and then fork and then exec this command. But like first it will have to set up the pipe based on the mode string, and then fork and then exec. Right. Okay. So, what did I just say that I wanted to do? Well, okay, so let's just do the pipe first. So let's say, I guess, how do we do this again? FDs? No, let's call it pipe FDs. Pipe is a very strange syscall. You pass in an int array of 2 ints, and it'll get updated with the 2 pipe ends. So let's do int_rc as pipe fds. And if that didn't work out, then we should definitely return null footer. Maybe we can even pair here actually, because but if we pair, then we're going to clobber erno. Let's check. What does it say in popen return value? I'm guessing returns null footer, right? If it fails, if fork or pipe fails, then we return null, and we set erno, right? So let's just do like saved erno, just in case. I don't want to lose it. Okay, now we have the pipes. then we want to fork, I guess. So pt child is fork if child, if not child. I mean, that means that we are in the child. So let's see. I mean, I guess you could interpret that as if I don't have a child. Call it child paid. Okay, then depending on the type. So what was the valid inputs for type? It was R or W. Anything else is unspecified result. All right. So if, I mean, we can just check the first thing. So actually, let's just say that if type is a null putter, or type is a 0 length string, then we'll just return null putter. And let's be good boys and say Erno is the inval. Okay. Because those are not even valid inputs. Okay. Then if type is, which one was it? The right end of the type. Right, so if it's R, then we should be able to read whatever he puts to his standard output. We should be able to read that on the file that we are making. So let's see. So then that means that we need to dup to the stdout file now to the oh god, which is which? Pipe. I don't remember. Pipe FD0 is the read end of the pipe, and FD1 is the write end of the pipe. So I guess this is going to go in the right end of the pipe. Let's see here. That's an ugly way of doing that. I have a temporary change thing. Let me try to use that. Saved. There, no. All right. Temporary change. Erno. I mean, can do that, and we'll just bring it back. It's a bit weird. Wait. Oh god, no, that's not what I want. I want it to be restored, so maybe we should make a new thing for that. Temporary change. Saver. Value. Saver. Store? I don't know. And then what would that be? Value restorer. And like that, and then we have the temp variable here, and then in the destructor we just m variable saved value like that, and we can just do that. Templates must have C++ linkage. Well, I'm sorry, I'll move it. Maybe we can also use a move construct. Or no, let's not do that. Let's do copy. But let's put that somewhere, like temporary change. Oh, he's in his own file. Let's just put it up top here. We'll see what how we like using it. Value restorer. Okay. Guess that's kind of all right. So now we're here, we're in the fork child, so I guess what we gotta do here is exit, really. Then it doesn't really matter what Erno contains, actually, so I was going down the wrong way there. Okay, so anyways, back on track here. Else if type is W. Then we're gonna dump to stdin file now. It's gonna be the other end of the pipe. And if that doesn't work, dump to, I don't know why it says pipe here, it's supposed to be like that. Alright. Exit 1. Okay. Okay, so now we have created set up the pipe, and we forked, we set up the pipe. I guess now all that's left to do is just exec. And what did they say about that? That the environment of the executed shell command should be as if a shell process were created using fork and then invoked using this call. Isn't that basically what system does? That's very much what system does. Except we don't wait on it like we do in the system. So in popen we don't wait. Right, so we just want to do this. And I think that's that. Okay. Now, what the heck do we do in the parent? So now we have the pipe. And depending on the mode, we're going to do some different stuff. So if type is R. Oh, yeah, right. And then else, I guess we should handle, or let's just handle the cases up here, I was thinking. If not type, or is not that, and type is not that. That's what I wanted to say. Okay, so those are all the valid values. We don't have to worry about that down here. Right. So, wow, this is like kind of messing with my brain, this whole thing, but we'll get through it. Okay. So we want to read from this pipe now. then he has opened, he's writing into this end, so we gotta read from the other end, which means that we're gonna have to create a file object wrapping pipefds 0. How do we make, yeah, we could use this make file with an FD. That's exactly what we do. So, let's make file pipefds 0. I'll do that. We'll say like that. Else if type is W, then fuse makefile pipefds 1. Okay. Okay. We can return that. Okay, but then what the heck does pclose do? Oh, here's an example. Let's borrow exactly this example, and then that'll help us. So let's see. Maybe we can even. I was thinking we could put this into the shell. Just be lazy and make it into built-in. So if stir comp argv 0, call it pope. And red file is pope. I'm just adding this as a built-in into the shell instead of creating a new separate program. Is that a good idea though? Well, see, now I feel stupid about this because probably it would be a lot more debuggable if it's a separate program. So, alright. Let's just do po.cdp. Refresh creator. Okay. And let's do anything. Blah, blah, blah. Yes, thank you, POSIX, for providing us with this glorious example. And we should do something here. Let's just add some output. Handle error. Well, I don't know. I guess we can handle the error this way. Okay, and return 1, and ls star. Let's do ls etc star. That'll be cool. Okay. Like C, use land. Oh, what? I need to actually build libc as well. Obviously. Let's see, and then we will sync and run. Okay. Well, we don't have a pclose implementation, so we're certainly not going to make it all the way through this program. I wonder how far it'll get. Oh. Well, see, that didn't work out very well. We asserted in popen. Why is that? 463. What? 463. Am I in the right file? Popen. Okay. That's really quite weird. Let's just do libc install. I wonder what that's about. Did I maybe forget to relink, actually? Okay, what? 463? That makes no sense. Am I like not even building this or what? I am building it. Okay. Let's just rm userland po. Somehow, like, this is just the perils of static linking. That the builds are just always screwed up and you get so used to it. Okay, here we go. So this is ls something, but it's not Etsy star. But I wonder if that even works. It doesn't work. So that's probably just an issue with the globbing code, actually. So let's do something other than ls Etsy star. And we should have a bug about that. Let me actually verify that this bug is like that. ls/star. Yeah, okay, that doesn't work. I'm gonna go ahead and file it because it's good to file bugs. And then we will do lsl/ instead. Maybe we can put something around this just to show that it comes from this thing too. Issues, where are you? Show globbing doesn't work right for to expand to every file in C, but doesn't. Crying smiley face. Labels. Bug. Okay. Cool. Pop. So that's definitely our output, but what happened with brackets that I tried to add? Let's just put these to make it real obvious what we're trying to do. Let's see, and we're removing that, and wait, are we? I almost get the feeling that ls is just going directly to the TTY here rather than actually going through the pipe. But I don't know if I'm right about that either. Why am I so suspicious of this? Oh, damn. Okay, so we're just not gonna read anything from the pipe and then just see if it works at all. Okay, I don't know what the heck happened here. Something went very, very wrong in the kernel. Okay, well, that's not currently the problem. Okay, pull. Oh, jeez. Okay, I'm just having the silliest problems here. Okay. Please, just tell me that you're not working so that I can make progress. Okay, yeah, so here we just fail, and then the output comes on std out anyway. So we know that it's not going through the pipe, so I didn't set it up right. Okay. Oh, and I think I know why. It's like that. because we have to close. Wait, how does this work again? Creates a copy of this one and puts it in the new FD. So am I just doing this backwards? I should be putting the copy like this, and then also closing the original. I think maybe that's that. Maybe I'm just reading this backwards. Yeah, here we go. Okay. Now we're getting this is one line, and here after the new line. So it's working exactly like you would expect so far. So let's see. Let's look in post-CPP. Yeah, so that was a problem. That I was mixing up how dep2 was working. Okay. Then what else do we want to do? I guess now we are asserting that pclose doesn't exist. So what's pclose supposed to do? I guess we gotta look that up. pclose, where are you? Here. The pclose should close the stream that was opened by popen, wait for the command to terminate, and then return the termination status of the process that was running. However, if a call caused the termination status to be unavailable to pclose, then pclose should return -1. So if like if someone else waited on the PID, or I mean like if somebody waited on, like you can wait on all children, then that would screw over pclose. So I guess in those cases we should also fail with each child. But it should not return before the child process has terminated. So basically it has to wait. And we are receiving this stream. So first things first is that we don't know the child PID based on a stream. So I'm just gonna do the obvious thing here and just add a PID field, because I don't see why not. PID T popen child. Let's call it that. And we'll say here that FP popen child is child PID. Okay. And here we can assert that stream, and we can assert that. I don't know why I'm calling it stream. I like FP is the convention, so let's just stick with that. Assert that it's not null. I mean, not 0. And then I guess we can wait PID. Popen child. Status, and God, what are the wait options? I don't even remember. Let's see. So if RC 0, let's just pass on the failure. Otherwise, we can return the status. Is that how it goes? and return the termination status of the process. Right, otherwise we give each child. I'll just forward the error from WayPit. W status. So what the heck are the args? No hang untraced exited continued. But we want it to hang here. So I'm just not going to pass anything. I think maybe that's fine that way. I hope I'm doing this right. Oh, if I'm not, then we'll eventually figure that out. Okay, seems to have worked. Oh, now something did not work. What did not work? Po is reading, sh is dead. That's really weird. This process is dead. SH is dead, but why is it not being reaped? I'm a bit dumbfounded, but it's definitely some kind of bug that we're having. Maybe not in the code I just wrote, but in some other code. But we should definitely be, like, no process should be sticking around in dead state. Dead. So let's see. Process die. So somebody probably already called process die for this guy. So let's just find him. Pid 16. Where are you, 16? We're unblocking him due to sick child. And then he sent a sick child to Po. But why are you never getting reaped? I don't get it. Normally the way that we reap stuff is in the scheduler, I think. Dead. Wait, process is dead. Return end dead. Oh, wait. So it's not the same as state dead? Why is it not the same as state dead? Past Andreas, why did you make it this way? Okay, so why do we believe that this process is not dead? M dead. What does that mean? Okay, don't worry about process tracer. We're not S tracing here, so set M dead true in process finalize. So I guess we never finalized this process. Well, when would we finalize it? If we call thread finalize. Finalizing thread in SHA-16. That's that process. Finalizing process SHA-16. And then we're sending a signal. Finalize process. I guess that it might be here. The issue might probably be that once we set the state to dead, then we are not going to be scheduled ever again. So, like, we'll probably end up, we'll do like as much of this finalization work as possible, but eventually the scheduler might kick in and take away our CPU, and then we'll never get scheduled again. which means that we can never complete finalizing stuff. So we should have, the thread shouldn't die here. It should die here. I think that's the solution, because we have to keep going until here. Yeah. Okay, let's try that. I have to go all the way to the end of finalize. Okay, pull. No, still not. Okay, finalizing process. And we're sending let's see, thread finalize dying threads. That's fine. Finalize. Well, wait. It shouldn't matter if this thing... Actually, yeah, it shouldn't matter if this thing is not schedulable anymore. Because this is supposed to be running in the finalizer task. So it's not the thread itself that's doing the finalization work, it's the finalizer task. So let's look at the finalizer. Oh yeah, right. So it's here. This is basically what it looks like. Is that it's just a loop where it just calls finalize dying threads, and then we block until there is a new dying thread. So does that mean that if I cause some new thing to die, then no, I thought maybe it would get unblocked, but it doesn't. Okay. So let's just print out here that we're doing it. Finalizing dying threads. Maybe we can say how many. Dying threads dot size. Okay, how many dying threads do you want to finalize? Finalize, by the way, means that we are cleaning it up, doing all this kind of cleanup work that doesn't require having interrupts disabled, or rather we're doing cleanup work that means that you can't have interrupts disabled. So like releasing various objects that may be holding locks, stuff like that, because there are many locks that you can't screw around with when interrupts are disabled, because that would be very deadlocky. So let's see, pull. Okay, now we're stuck. And wait. I feel like I didn't get that output that I wanted. Why do I never get any output changing? Okay, am I even editing the kernel? Sometimes I wonder, but yeah, it seems like I am. Let's just say XXX for help. Invalid use. Okay, so that was not right. This is really strange. Does this thing ever print anything? Why is this not printing? This is so sketchy. Somebody's finalizing these things, right? I mean, yeah, we can see that they're being finalized. But why doesn't it? Oh, I'm so stupid. Oh, shit. It's because... it's because we changed the way that boot process works. So now we're running with grub, which means that I have to actually sync even when I'm editing the kernel. Otherwise the kernel doesn't end up in the file system. Yeah, there it is. Finalizing one dying thread. Okay, here we are. Finalizing one dying thread. And now what? What's up, finalizer? He woke up. So the finalizer is done here, but what went wrong? So he's sending, the last thing that should sh here does is send a child signal to PO. But that is true. Then he should be marked at this point. So let's say marking this guy as dead. Okay, and then mname characters pid. Okay. And let's actually remember to sync this time. Po. Marking sh16 is dead. Okay, but is that actually what things look like? Sh? Wait, which one was it? sh16. Oh yeah, this 16 here is dead. So his mdead is true. Right, and then that's checked by is dead. And is dead is checked by the scheduler. But I guess he has a parent. So the parent is expected to wait on him. Right, the parent thing. So his parent is 15, which is Po. And Po is in read. So Po got sick child, but Po is in read. So then, what's supposed to happen with him? He's just doing fgets, and I guess this should fail. Why is this not failing? I feel like we should fail with epipe or something here. So fgetC calls fread. Fread calls read, and if we fail in read, wait, fread is supposed to return a size t. Yeah, okay. So fread calls read, and if read fails, then we set the stream error, and then we return 0. Okay. So say that it failed. Then fgetC has failed, here, and we now have an error. Suppose that this code here is actually a bit wrong because fread has already set the stream error, so we don't need that. Yeah. Okay. If you can see. Okay. And then where were we? Fgets. Fgets is calling fgetc. Okay, so we get an e off, and then nred is 0. And return null putter. So we should be failing to read, but we're blocked in the read call. Why is that? Finalize. So I'm thinking, like, what the heck could be causing this? So between these two processes, there's a FIFO right now. And the call to finalize should kill the FIFO on the child side. Here, mfd's clear, which will clean up all of the file descriptors, which means that they will have their thingy here called, and we will, for each FIFO of these, we'll call detach. Which means that we will remove a reader or a writer from the FIFO. And can read, let's see, can write. So this thing is never returning true. But there should be 0 writers, I would think. So let's just say, so can read is how select is implemented and also how blocking read and write is implemented. So this sort of tells me that you should be able to read from a FIFO if either there is some data or if there's no person on the other side of the FIFO. So let's see, FIFO can read is empty is, and writers is that. Okay. Let's find out what this looks like when we're in that state. Because can read is going to get spammed. So it's happening right now. The buffer is empty, but there's still a writer. And why is there a writer? Because the SH program, I guess it's still live. That's so weird. MFD's clear. Because, wait, what's going on here? Clear with capacity. Well, I'm just getting sidetracked in vector here. So it should really have been clearing all the file descriptors, and those that were FIFOs should have been detached. There shouldn't be a writer. hold on. Is it because I have to also close it in the parent process? So like, I'm making a file for this one, then I should also close pipefds1. Is that how that works? Let's see, so what does that do? I'm just thinking, like, is it the parent process that actually has the other end of the pipe still open? Is that why we're seeing this? Yeah, I think that's why we were seeing that. Right, so the parent process was keeping his end of the, or both ends of the pipe open, which obviously was not good. Okay, well, glad I could figure that out. Okay, so let's see, we added some irritating debug stuff here, so let's get rid of that. Like that, and marking something as dead, and xxx somewhere here, right? And okay, I think we are ready to do a patch review. So let's look. Yeah, we don't need that change, so let's just do that, and but let's also double verify that I'm right about this. But I think we don't need that change because it's the finalizer running the finalize code and thread. It's not the thread itself, so it doesn't matter if it can't be scheduled ever again. Right, yeah. So that's good. Okay, so back to the patch. So here's that value restorer thing that I added for a single user. That seems really excessive. But it is also a nice, useful thing. So let's add it to app. And we'll put it here. And that, and we'll do a little pragma ones, namespace ack, value restore. Okay. And then we can just pull it in like that. Yeah. Big build in the background while we look at the rest of the patch. Okay, so value restorer, by the way, is a very, very simple template class that just remembers reference to any variable and whatever value it had, and then when we go out of scope, then we restore that value, whatever it was. Simple as that. Okay, so here we are skipping overwriting the stream error because that was already done by fread, which should be fine. I mean, it's a little bit of an unrelated change, so I don't like doing unrelated changes like this, so maybe I should put that in a separate commit. Just do it like that. Okay, so then we only have popen and pclose to look at. So popen, what do you do? Well, first we check if type is null or if type is not R or W. And then we don't care if the string is longer. We just care about the first character. Because I'm lazy like that. Deal with it. And then we create the pipes. And if that fails, then we save error no, so we don't clobber it. And just pair the pipe error and return a null pointer. Okay, and then we fork, and if this is a read popen, then we take the standard out of the child and plumb that to the second pipe FD, and then close the second pipe FD. Does this mean that we should also close the first pipe FD in the child? Close pipe FD 0. Because we inherit both of them, so maybe we should close both of them. Because now this one is insted out and this one is insted in. So because you inherit the file descriptors from your parent when you fork, I think we should close both of them for the bookkeeping to be really correct here. Yeah, that looks the same, but yeah, I think that's the way it's supposed to be. But we'll find out eventually if I was wrong about that, but I think that makes sense. Okay. Right, and then yeah, so depending on the direction, we just we dump to either to standard out or standard in. That's fine, whatever. Okay, and then we exec, and if exec fails, then we print an error and then exit. Right. Then we make a file stream for the end of the pipe that we care about, and then close the other end. And then we put the child PID in the special stream variable. Cool. That's just so that we can get there later with pclose, which is just where we wait on that PID and return the status. I think that's good. Okay. I feel reasonably happy about this. So let's say implement basic implementation. No, implement popen and pclose. Feel reasonably confident that I might have gotten these right. Yeah, all right. Let's just see that program run one more time. Okay, cool. I think we have popen and pclose. I hope I did it right. Otherwise, I'll be back here fixing it up eventually. But I think that turned out pretty good. So if you made it this far, then I thank you for watching and for coming back and hanging out. And I will see you next time.